Hi, Danny.
Hello. How are you?
Good.
Good.
Hello.
Good. Hello. Hello.
Hello, I had to rejoin because it wouldn't let me in.
Yeah, I had to admit everybody, so it takes a minute. How is everybody doing?
Good.
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 So far, we still have water, but I don't know how long that'll be. So it's been interesting around here. Anybody ever had their water cut off before?
No.
Have had power outages.
Yeah, it's the same thing. You know how when you have a power outage, you just stupidly flick the light switch like something's going to happen? Yeah, we're all going to turn on faucets like something's going to happen. But yeah. What now?
Why is your water cut off?
So we got our water bill, and when I looked at it, I was like, "Whoa, this is way too high." So I looked into it to try and figure out what in the world made it so high. And it's usually when it's like that, something's leaking. So it's nothing inside the house. So we went and checked to see if it was the sprinkler system, and we had some guys come out and they did some of their own stuff, and it wasn't the sprinkler system. So we were able to determine that it's somewhere between the water meter at the street and the house, which means it's like leaking underground. Maybe there's a big lake under us. I don't know. Probably filling some kind of an aquifer with Forsyth County water, but we're losing like a gallon a minute. So
Whoa.
fun. Yeah, right. So they're going to come sometime today. It's a company that does like this really cool sonar thing where they're going to shoot air down into the lines, and then they will listen with their sonar equipment to hear where the bubbles are. And when they know where the bubbles are, then they'll be able to pinpoint the leak without just digging up the whole yard, which is sometimes what they have to do. So
That's
I'm just
cool.
hoping, yeah, I'm just hoping it's not under my cherry tree. Jason's afraid that the roots of the cherry tree have grown too much and bled into a line, which sometimes happens. So let's hope not, because I like my
Don't
trees.
get rid of the cherry tree.
Yeah, we'll have to reroute it no matter what. All right. So I ended up throwing together a last minute slideshow to go along with our lesson because I wanted to have stuff for you guys to look at today too. And I did it for like an hour and a half last night, and then this morning it was gone. I have no idea what I did with it. So
What are we gonna do for lab?
yeah, so then I did it again.
Is there just a video or no?
For lab. So lab today is
We're
actually,
doing periodic table battleship.
yeah, periodic table battleship.
Can you wait a minute? I forgot my lab notebook downstairs. Can I
Sure,
do
go
that?
right ahead. It's gonna take me a minute anyway to get everything together. So, all
I'm
right.
cold.
Okay, I'm gonna screen share. Done. So I did give you guys a cool, I don't know if this moves like it did in the original picture. Oh, no. Okay, that's fine. Whatever that was. There it is. Okay. Introduction to atoms. So we'll wait for Senia to get back up here. But by the time y'all get back, hopefully the house will be done or close to done. They've done the deck. That's all done except the gate. And now they are doing all the wood around the windows, which is so much fun because they have to bang. And yesterday they were tearing off a whole window, and it was the dog was losing his mind because it was bang, bang, bang constantly and super loud.
Did they take out the window?
They didn't take out the glass, but they're taking out the wood around it. There we go. There she is. All right, here we are.
I think if they took out the glass, I think Ozzy would think that was an exit.
Yeah, he might. He was already thinking there were like some kind of terrible, horrible monsters trying to get in the house. So, all right, so let's look. You with me? Drew's over here, by the way. Say hello. There you go. Hey, Drew. So we're gonna go ahead and start our lesson for today. So introduction to atoms. I like this picture. I think I could stare at it all day. It's kind of satisfying, kind of hypnotic, isn't it? So last week I showed you guys a video, right, that had the evolution of atomic theory. I'm pretty sure yep, that YouTube video. So here's instead of doing the whole video again, here's a good timeline. So atomic theory, as we know it today, hasn't always been exactly as we see it. So way back when, Democritus, we're talking like ancient Greeks, right? So he actually proposed that matter could not be divided into smaller pieces forever. So he said that matter was made of small, hard particles that he called atoms, which came from a Greek word atomos, about being the smallest particle. He kind of thought of it like marbles, little tiny marbles that made up everything. Sort of like a sand castle is made of little grains of sand. He kind of thought everything was like that, just on a much, much smaller scale. And then many, many years later, we get this dude, Dalton. I love how these are all like normal animations, and then there's this random Simpsons guy in here for, for Niels Bohr. It's pretty cool. So anyway, we get Dalton. Dalton has the first atomic theory. So he viewed atoms as tiny, solid balls. And he was kind of coming from what Democritus had said. And then these guys were all around the same time. This Dalton, Thomson, Rutherford, Bohr, Chadwick, they aren't that far apart in the scale of time, but this guy was like way before then. So Thomson comes up with this thing where he shows that an atom was made of even smaller things. So he has this idea. See, Dalton had this atomic theory, and one of the things he said is that atoms can't be divided into smaller particles. But he was proven wrong, because we know that atoms do have smaller particles, right? Atoms are made of other particles. And Thomson, see, it says here, his atomic model was known as the raisin bun model. Well, it's also known as the chocolate chip cookie, which is what the video said last week. And it's also known as plum pudding or chocolate chip pancake or anything else you can think of that is kind of a homogeneous blob of little things inside of it. Can you think of something else what's another good sweets reference? What would be a good reference? What you got, Senya?
Strawberry bread.
Strawberry bread. Ooh, that sounds good.
My mom makes it every year.
Apple pie.
Really good.
Apple pie. There you go, with like big chunks of apple in it. How about mint chocolate chip ice cream? There you go. Same idea, right?
Give me one sugar.
Ooh, I know. So this is what this guy wanted. Thought was the case. This is what he wanted to show out to the world. And then Rutherford came along, Ernest Rutherford, and he discovered protons and a nucleus. And so what he showed is that atoms have positive particles in the center, and they're mostly empty space. So we talked about that a little bit last week, especially when we showed that video. And this is interesting. If you really want to get into a fun rabbit hole of reading interesting things online, you can look up what's in the, sorry, I have a friend calling you. You can look up what's in the empty space, because if you think about it, a good visual is if the nucleus of an atom is about the size of a marble, we have to envision this. If you could blow a nucleus up to the size of a marble, do you know how big the whole atom would be? What would be your guess? For scale, what do you think?
I don't know.
A football field, a whole football stadium, actually.
Whoop.
Hang on, she doesn't usually call me during the day. Sorry guys, but that might be an emergency. I am there. She never calls me during the day. So. All right, so anyway, yeah, if you could blow up an atom to the size of a football stadium, think about like in Atlanta, the football stadium, right? Big. Then your nucleus would only be the size of a marble. And your electrons are really tiny. They're just buzzing around in all that space, like the size of the stadium. So what's in all the empty space? It's not really empty. There's actually stuff going on in there, which is pretty fascinating. And it's not anything you really like have to know for middle school chemistry, but if you want to get into a fun rabbit hole, that's a fun rabbit hole. So after Rutherford came Bohr, and Bohr proposed that electrons move around the nucleus in specific layers or in shells. When we model atoms or draw them out for a diagram purpose, we typically do them kind of like Bohr, because it's really hard to visualize atoms the way they truly are. And if you draw them out the way Bohr drew them out, it's easy to count the electrons and kind of see what you're looking at, or envision what these little tiny things actually look like. Because by the time you see it like this modern one, and I'll show you another one in a minute, it gets really complicated. So Chadwick here, he discovers neutrons. He was working with Rutherford back over this way. And neutrons have no charge. And then lastly, we get this modern theory. And I'm going to show you some other pictures in a minute that kind of give you a better idea. But the concept is that the electrons are moving around the nucleus in a cloud, not in perfect little orbitals. Sometimes they call Bohr's model here the planetary model, and it looks just like, doesn't it look just like orbiting planets? Like the way we draw the solar system?
Kind of.
Yeah, it does. So this would be an example of Bohr, right? This is how Bohr drew out his atomic model. So this is a structure, and like I said, we usually use Bohr because you can see it. So this is argon, and our atomic number is 18. There's our atomic weight, and then it talks about how many electrons per shell, because the top Bohr did know they were in different energy levels, and that's true, they are, but they're not necessarily round like this. I'll show you in a minute a picture of the shapes they actually are. They're not really round like that. So if you look here, what lives in the nucleus of an atom? What two particles hang out in there? Who knows?
Nucleus.
In the nucleus. What's in the nucleus? You guys know. What's in there?
Proton and neutron.
Good job. All right, yes, protons and neutrons are in the middle. And neutrons have no charge, right? And protons have a what?
Positive charge.
A positive charge, right? So then we have our electrons, and they go whizzing around the nucleus. But like I was saying, it's really much more complicated. So catch this. Atomic particles, so your protons, neutrons, and electrons, have even smaller particles. And they've named these particles, and it's crazy. I mean, they have these leptons and then quarks, and quarks have something to do with wavelengths of light, and it gets really, really complicated. But you may hear people talk about, you know, like quantum physics, and they're getting into this little itty bitty stuff. Like check out tau, muon. Isn't that interesting? And there are up quarks and down quarks, and this one's strange. It's just strange, but this one is charm. So I like this guy, but this guy we're not so sure about. And then atomic orbitals vary in shape. So when you look at that Bohr model, remember they were round, all round. Look like you threw a stone in a pond and it rippled out, or like a planetary model. But truly, they're more like this. And your first energy level of electrons are round, like that. And then your second, like spherical, like a ball. And your second ones are kind of like a dumbbell shape. And then this next energy level up is like two dumbbells stuck together this way. And then you get into these really strange, like donut-shaped ones. And here's the thing, this isn't the path the electron takes. It doesn't go, you know, figure eight like this around this dumbbell shape. It actually is a way to diagram where you're most likely to find that electron, because they go kind of all over, right? And they will go in opposite directions too. So if one is moving this way, the one next opposite it will go this way, which makes sense because they both have the same charge, and like charges are going to repel. So they're, yeah.
Are we gonna check our lesson 6 stuff today?
Yeah, we will.
Okay.
There. So they vary in shape. So just remember that when we draw a Bohr model or envision a Bohr model, because it's just the simplest thing for our little feeble human minds to do, they're really way more complicated. So particle masses. Which particle has the most mass? No, which particle though? Do we know? So actually neutrons have the most mass, and it's a little tiny bit more than the proton, but not so much that it's going to show up in this kind of a measurement. If you were to get even more specific, put even more decimals, you would see it. So but protons and neutrons have way more mass than electrons. Electrons have almost no mass. They're so small. So if you look at them relative, these guys are about the same, and this electron has almost no mass. It's very, very tiny. So technically your neutrons have a little bit more than your protons, but not a whole ton more. Everything is so small, it's hard to envision. So then isotopes. Did anybody remember what isotopes are? Who can tell me about isotopes? Isotopes. You're thinking. I see thinking brains.
Different neutrons.
Yes. Who said that? Jules, was that you? Yeah, good. I was scrolling faces. Yes, different number of neutrons. Okay, so that can mean, so if you have an atom, let's say you have 4 protons, you're usually going to have 4 electrons, and typically you'll have about 4 neutrons, but sometimes you'll have 3 or 5. And isotopes are different because their mass is different. They're, oh, are you trying to see them? He's trying to see you. He's been in my lap this whole time because he's a big baby. So these are actually isotopes of, does anybody know what element that is right there? You know?
Hydrogen.
That's hydrogen. Yeah, okay. So these are different isotopes of hydrogen, and they actually call this one protium. And they call this one deuterium and this one tritium. So if you look, hydrogen typically doesn't have a neutron, right? This is how you usually see it. But if you look here, it's got 1, and here it's got 2. Now, isotopes are fascinating, and you get into more advanced chemistry, you can learn how they decay, which means that over time, they will actually lose mass, or typically lose mass, and they can start to behave almost like a different element. But what's really neat about that is we know the rate at which they break down. And because we know how long it takes for them to break down, we can use isotopes like carbon-14, for example, which carbon is usually 12, so 14 is a little heavier. And we can measure that atomic mass and tell exactly how old something is if it's composed of that particular carbon-14 element, which is how they do carbon dating to stuff that is thousands or hundreds of thousands of, or sometimes even way more than that, years old. It's really, really cool. And sometimes
Sounds cool.
it's very cool. If it's something within the last, several thousand or 100,000 years, sometimes they can narrow it down to a time frame of only about 200 years. And that's
Whoa.
crazy, right? That's crazy that they can do that. Because think about fossils. So when you're dating fossils, you can choose either to look at what else is in the same layer of earth that you're digging up and go, oh, well, we know that this particular animal lived in this time frame, so these other things are in the same layer, so they must be about the same age. But with carbon dating, you can get really exact. It's pretty fascinating. So that's what we use isotopes for, just one thing. So we have atomic number versus mass number. All right, so your atomic number, that's going to be the amount of protons in the atom. So we don't really have a number that tells you the amount of electrons in the atom or the amount of neutrons in the atom. We go with protons because that stays the same. And you have isotopes, which means you could have different neutrons. And then later we'll get into ions, which means you can have a different number of electrons. But our protons are not going to change. So that's why we use protons for atomic number. So hydrogen's atomic number is 1, right? It's got 1 proton. Now, mass number is the sum of the protons and the neutrons. So they just add them up. That's all you do. And there's a specific number that's got lots and lots and lots of decimal digits after it, right? But typically what we do is we just consider everything to be about 1. Does somebody have a question? No? Oh, yes, no. So if you typically have 12 here, then that would probably mean you've got, 6 neutrons and 6 protons in that nucleus, because we consider them both to be about 1. Remember that chart? Eleanor, did you have a question?
Yeah, why is the lab called the periodic table Battleship?
We'll get there. We're going to play Battleship. You ever play Battleship?
I love Battleship, even though I've never played it before, but I've seen people play it.
It's fun. We'll get there. So I got a little video about Mendeleev we're going to watch. So you guys read about Mendeleev, right? He's the guy who's credited for organizing the first periodic table. He didn't do it all on his own. He came up with the idea based on some things some other people had done, but he was the first person to make it a thing. So I don't know if it's going to play in here because, like I said, I had to throw it all together kind of last minute. But if not, I can pull him up. Are you going to play? Look at that. It's going to make me crazy. I had it all done and then it just didn't.
You
work.
can just go on YouTube and search it.
Well, I can, I know, but here, we'll do that real quick. I was trying to see if I could get him to go within the thing like he's supposed to do. Ugh. Oh, no, I can't. There.
Your computer is rebelling against you.
Yeah, sometimes this is what happens in life. Yeah.
My earbuds rebel against me. Like they're like
Your
nope.
earbud.
And yeah, like sometimes they like unplug themselves.
Whoops. Whoop, Ted. So Mendeleev, this guy, I got some great stuff about him I'm going to show you in a minute. So I love Mendeleev. He's one of my favorites. Oh, we got a commercial. Gotta love that.
Starts here with our
Can't watch a video without a commercial.
Diamond Orchard in California.
Anyway, here we go. It's a short one.
I don't see the video.
Yep, it's coming. There you go. Hang on.
Rhenium.
Oh,
The
he's in the
element
middle of it.
ecomending.
Why are you doing this to me, computer? There you go. Now we got it. Sorry, gang. Hey, you paying attention? Okay. I love TEDx.
The periodic table is instantly recognizable. It's not just in every chemistry lab worldwide. It's found on T-shirts, coffee mugs, and
I don't see it.
You can't see
Periodic
it?
table isn't
Yeah,
just-
same. All I see is the picture
map.
that you showed us when it wasn't working.
Okay, hold up. What is the deal? Oh,
It doesn't like you anymore.
it doesn't.
Yeah, everything's
Can you see it
rebelling
now?
against us.
Now
No,
you see it?
It's
I
still
can't see it.
Really? Huh.
Yeah, still just picture.
Hold on here. What in the world?
Computers are taking over the world, starting with
are.
editing PowerPoints.
See, I had it all saved too, and that's what's
Yeah.
crazy. Stop share. Okay, let me go back to share. There we go. Now you see it?
Yes.
Yay!
Yay!
Thank you.
The periodic table is instantly recognizable. It's not just in every chemistry lab worldwide. It's found on T-shirts, coffee mugs, and shower curtains. But the periodic table isn't just another trendy icon. It's a massive slab of human genius. Up there with the Taj Mahal, the Mona Lisa, and the ice cream sandwich. And the table's creator, Dmitry Mendeleev, is a bona fide science hall of famer. But what?
Oh, don't do that. I just made it bigger.
What's so great about him and his table? Is it because he made a comprehensive list of the known elements? Nah, you don't earn a spot in Science Valhalla just for making a list. Besides, Mendeleev was far from the first person to do that. Is it because Mendeleev arranged elements with similar properties together? Not really. That had already been done too. So what was Mendeleev's genius? Let's look at one of the first versions of the periodic table from around 1870. Here we see elements designated by their two-letter symbols arranged in a table. Check out the entry at the third column, fifth row. There's a dash there. From that unassuming placeholder springs the raw brilliance of Mendeleev. That dash is science. By putting that dash there, Dmitry was making a bold statement. He said, and I'm paraphrasing here, y'all haven't discovered this element yet. In the meantime, I'm going to give it a name. It's one step away from aluminum, so we'll call it Eka aluminum. Eka being Sanskrit for one. Nobody's found Eka aluminum yet, so we don't know anything about it, right? Wrong. Based on where it's located, I can tell you all about it. First of all, an atom of Eka aluminum has an atomic weight of 68, about 68 times heavier than a hydrogen atom. When Eka aluminum is isolated, you'll see it's a solid metal at room temperature. It's shiny, it conducts heat really well, it can be flattened into a sheet, stretched into a wire, but its melting point is low, like freakishly low. Oh, and a cubic centimeter of it will weigh 6 grams. Mendeleev could predict all of these things simply from where the blank spot was and his understanding of how the elements surrounding it behaved. A few years after this prediction, a French guy named Paul-Émile Lecoq de Bois-Baudran discovered a new element in ore samples and named it gallium after Gaul, the historical name for France. Gallium is one step away from aluminum on the periodic table. It's Eka aluminum. So were Mendeleev's predictions right? Gallium's atomic weight is 69.72. A cubic centimeter of it weighs 5.9 grams. It's a solid metal at room temperature, but it melts at a paltry 30 degrees Celsius, 85 degrees Fahrenheit. It melts in your mouth and in your hand. Not only did Mendeleev completely nail gallium, He predicted other elements that were unknown at the time: scandium, germanium, rhenium. The element he called ecomanganese is now called technetium. Technetium is so rare it couldn't be isolated until it was synthesized in a cyclotron in 1937, almost 70 years after Dmitri predicted its existence, 30 years after he died. Dmitri died without a Nobel Prize in 1907, but he wound up receiving a much more exclusive honor. In 1955, scientists at UC Berkeley successfully created 17 atoms of a previously undiscovered element. This element filled an empty spot in the periodic table at number 101 and was officially named Mendelevium in 1963. There have been well over 800 Nobel Prize winners, but only 15 scientists have an element named after them. So the next time you stare at a periodic table, whether it's on the wall of a university classroom or on a $5 coffee mug, Dmitri Mendeleev, the architect of the periodic table, will be staring back.
That's cool, huh? I like it.
It would be creepy if he was actually staring back, though. That would actually be creepy on the mug.
Just a little. So, Mendeleev, I've got some fun stuff about Mendeleev for you, because I really like the guy. He's definitely one of my favorites. So, here he is. Ta-da! Can y'all see him in his fancy frame there?
Yep.
Yep, all right. So in 1865, he expanded on Newland. That's the guy who came before him, John Newland. He just expanded on Newland's idea, and he placed the symbol, characteristics, and atomic mass of each element on a card and then began arranging them. So he began to teach inorganic chemistry at the university, but he couldn't find a textbook that met his needs. So since he already published a textbook in organic chemistry in 1861 that was awarded the prestigious Demidov Prize, he set out to write another one. The result was, and I'm going to try this, I don't speak Russian, the Osnovki Chemii, the Principles of Chemistry, which became a classic running through many editions and many translations. When Mendeleev began to compose the chapter on halogen elements, chlorine and its analogs, at the end of the first volume, he compared the properties of this group of elements to those of the group of alkali metals such as sodium. And within these two groups of dissimilar elements, he discovered similarities in the progression of atomic weights. And that's what made him start thinking. So then he wondered if other groups of elements exhibited similar properties. And after studying the alkaline earth metals, Mendeleev established that the order of atomic weights could be used, or atomic masses could be used, not only to arrange the elements within each group, but also to arrange the groups themselves. So thus, in his effort to make sense of extensive knowledge that already existed, he came up with this whole idea of the periodic law, which is what establishes the periodic table. So he's a cool Russian dude, and he's one of my favorite scientists. So here's a copy of his first tables. This is actually copies of the actual documents that he made, which I think is incredible that we still have this. This is his little chicken scratch writing.
I can't read it.
Yeah, well, I can't read it either because
Didn't he
it's in,
think of it when he was in the bathtub or something?
no,
I
it's
can barely
Cyrillic.
read cursive.
Well, it doesn't even matter because it's Cyrillic, which means it's the Russian language. So I can't read Russian. I've sung in Russian once. I have no idea what I was singing, but I
wish I brought my friend John Lucas.
yeah. You got
He's-
somebody who speaks Russian?
He's from Russia.
Oh, okay. Yeah.
He was born and raised there for 8 years, so he can
Oh,
write, speak, do everything in Russian.
that's really cool. But I just think these are neat that we still have all these little notes, and you can see where he kept changing his mind over here. I love that. So what's to love about him? A lot. But can we start with some of his cool quotes? I have some cool Mendeleev quotes for you, just because I think this guy is really fun. All right, how about this one? The establishment of a law, moreover, does not take place when the first thought of it takes form, or even when its significance is recognized, but only when it has been confirmed by the results of an experiment. Okay, all right, that's kind of sciencey. He's got some other ones though. Work. Look for peace and calm in work. You'll find it nowhere else. Well, that's a message, isn't it? You're only going to find your peace and calm in your work. There's no talent, neither genius, without hard work. Oh, this guy has a work ethic,
That
clearly.
is so true.
I love this one. the most all-penetrating spirit before which will open the possibility of tilting not tables but planets is the spirit of free human inquiry. Believe only in that. Okay. But this is my favorite. Mendeleev gets picked on a bit for these piercing eyes, right? He looks almost menacing in some of his pictures. So you get stuff like this now. My favorite element, surprise, stabs interviewer. Clearly that's not real. But doesn't he look like it? I love it. Doesn't he look? I mean, look at him. I love the guy. He's great.
I had to take a screenshot of that.
So in 1850, he walked almost 1,000 miles to Moscow so he could apply to the University of Moscow. Although he was not accepted, he walked to St. Petersburg where he was accepted. And with that education, he developed the periodic table of elements. Okay, he can walk too. He was the youngest of 17 siblings, youngest of 17, of whom only 14 stayed alive long enough to be baptized, which means a lot of them probably died shortly after birth. But according, oh my goodness, but according to his brother, the exact number of siblings differs among sources and is still a matter of historical dispute. But this is interesting. This is probably why he didn't get as much credit as he deserved. So in 1876, he was still married, but he became obsessed with this lady named Anna Popova, and he started basically chasing her. And she was like, no, you're married. I don't want anything to do with you. So he's like, oh, well, if you don't like go out with me, I'm just gonna kill myself. Literally. Yeah, he threatened suicide. So then he divorced his wife and married her. And he was part of the Russian Orthodox Church because pretty much everybody in Russia was part of the Russian Orthodox Church at that time. And they required 7 years separation before a lawful marriage. So because his divorce and new marriage were so quick, it basically barred him from the Russian Academy of Sciences, which he definitely would have otherwise been not just a member of, but like a key figurehead of. So that non-scientific, outside of the realm of professional behavior is what wrecked a lot for him, actually. So getting towards the end of this lesson, because we got to wrap it up soon, we've got our periodic table divided in 2 ways, into groups and periods. The groups go vertically, and you're going to be using this a lot in your lab today. The periods go horizontally. And the periods run horizontally, and this is the way that that numbers in the periodic table go, that atomic numbers go consecutively, right? Just like you would read, right to left, horizontally. And the groups have the same number of valence electrons. And valence electrons, if you remember, those are the ones in the most outer shell. And they matter because they're the ones that interact, okay? So I'm gonna come back to this in 1 second. But I want to pull up your homework real quick and make sure that we have that all taken care of. So for homework, you guys were to do the periodic table. Some of you have already gone ahead and done the whole thing, which is good because that's just less homework you get over break. There you go. Yep, a couple of you already did it, which is fine. It's fine. And for those of you who didn't, no big.
Wait, when is break?
Well, break is next week. There's fall break next week. Okay. So for your assignment, we're just going to cover, make sure we have all the answers for these. So I have my answers at the bottom of the page. If you have them and we want to check them. So what 3 particles are found in an atom? And we all know that. What? Protons,
Proton, neutron, and electron.
Very good. Let's see. Number 2, which 2 particles are found in the nucleus?
Protons and neutrons.
Protons and neutrons. Okay.
Did we need to write that stuff down on this page?
No, you just have to be sure you know
Okay.
it. If you wrote it down, great. Explain why scientists use models to study atoms.
Because they're too small to see and it helps them.
They're very small and very complicated too. Which 2 particles in the atom are roughly equal in number? Or equal in number?
Protons and electrons.
That's right, yep. And most of the time that's true until we get to ions, then it's not so much. How are elements identified in terms of their atoms?
Atomic Mass.
Atomic number, which is the number of what? Protons, right? There you go. All right. So what's the answer for number 7? Somebody read me the sentence with the correct answer in it. Go ahead, Sonia.
The nucleus is the very small, dense center of an atom.
Very good. Who wants to do number 8? Anybody? Go ahead, Jocelyn.
The positively charged particle in an atom is called a proton.
All right. How about 9? Who wants to do 9?
A negative charge.
Jocelyn again.
A particle with no charge is a neutron.
Very good. All right. Who wants to go this time? Sonia again. Her hand's up. Yeah.
I'll go.
Go ahead.
An electron is the particle of an atom that moves rapidly in the cloud-like region around the nucleus.
Good deal. All right. 11. Who wants 11? Anybody want 11? Ella, you guys? One of you guys want it? Jules, do you want 11? No? Eleanor, you want it? No, she disappeared. 11. The atomic number. Oh, you can do 12. The atomic number tells the number of protons in the nucleus of every atom of an element. All right, how about 12 then, Senya?
Okay. Atoms of the same element that have the same number of protons but different numbers of neutrons called isotopes.
Very good, isotopes. All right, how about 13, Jocelyn?
The sum of protons and neutrons in the nucleus of an atom is the mass number.
Mass number in the nucleus. Good deal. All right, and then 14, scientists often use a model of an object, helps explain ideas about the natural world. All right, I'm just going to read the answers for these. You can check them over. Are you checking over here? Are you checking? All right.
I have it.
So, number 1, atomic number. Number 2, chemical symbol or symbol. Number 3 is name. I'm not checking. Number 4 is atomic mass. Number 5 is Mendeleev arranged the elements in order of increasing atomic mass, or something close to that. Number 6 is elements in a column have similar properties.
Wait, what was number 5?
Mendeleev arranged the elements in order of increasing atomic mass. Number 6 is elements in a column have similar properties. 7, you can predict an element's properties. Number 8 is period. Number 9 is atomic mass. And number 10 is chemical symbol or symbol. Good deal. All right, now the end of our PowerPoint. Can y'all see it?
No.
Do you see the PowerPoint or no?
No.
Okay,
Can't see it.
does that, Tammy? I don't know why it does that. It's weird. Don't do that. Now you can see it, right?
No, it's now. I can't.
What's it say?
Next week, 9:20.
Fall break.
Fall break.
Fall break. Okay. Then it will be almost October. And you know what that means. At least some of you do. What happens?
I don't. All I know is that
October. Lily knows. Lily, you know what happens in October.
Halloween.
Halloween. What else happens in October? What's my favorite holiday? Drew just said it. What is it? Tinker Day. Okay, so Tinker Day happens in October.
Day, I
I
forgot.
don't know what
You're
Tinker.
like, what? Okay, Jocelyn, you're not allowed to say
I
it yet.
forgot.
What?
You have to know what.
My name.
So yeah, you have to know what Tinker Day is. So Tinker Day is a holiday from my college, and it's just specific to my college. And I'll be sending out some info, but it's going to happen someday in October. We don't know when it is. Whenever it is, there will be donuts. So we have to figure out how to get some donuts to the Caro family. Now, I know Ms. Laura better have some donuts for Jocelyn because Miss Laura is a Holly Collie too. And if she doesn't, I'll disown her. So whenever Tinker Day,
You said that.
you tell her. And if Tinker Day happens to fall on a day that we are not in class, then there will be extra credit points given to anybody who takes a picture of themselves eating a Krispy Kreme or the closest thing you can find dressed in green and gold every year. It's my thing. Okay, so lab is coming up shortly. And if you can come and do it live, that's best. If you can't, it's not going to be the end of the world. But because you can always still do it on your own. There's lots of ways to do it on your own. But if you can come and do it live, be sure you have checked your email and printed out the document I sent. You're going to need a periodic table. And we're going to play Battleship, which is basically, if you've ever played Battleship, you put little ships on the board and then you give coordinates and try and guess where your opponent's battleship is. You can,
And then if
Oh, I've played Battleship once.
yeah, it's fun. Yes, Eleanor.
Can I ask what people are being for Halloween?
Oh, hang on. Let's wrap up first.
Okay,
So
sorry.
we're gonna do. No, you're fine. So we're gonna do periodic table Battleship. We're gonna start at 11 because I need a minute to get everything ready here. So have your paper ready. If you have a plastic sheet, you can stick it inside of, so you can use like a dry erase marker on it. That's great. Oh, see, Jocelyn's got one. Perfect.
I got a folder.
There you go. If you don't have that, then just, get a
A big
pencil.
piece of paper.
There you go. Yeah, if you can just print it and get a piece of paper that you can write on lightly with the pencil and then erase, that's cool too. Because what I'm gonna do is we're gonna go over the rules and then I'm gonna divide you up into rooms and
Oh,
give a certain time
Oh, we're
period.
in different rooms in this class.
Can we choose our partners?
I'm probably gonna do it randomly. I don't know. I'm
One
gonna
second.
look and see. Yeah.
What about people that are muted and like have their thing off?
Well, they shouldn't be, because once you get into the rooms, you should be able to see each other and play. So
Okay.
even if you don't see each other, you should be able to hear each other, definitely.
I played Battleships a long time ago, so I don't really know how to do it anymore.
Well, I got rules for you. So you
I
know
played it when I was I played it when I was 2 years old,
Battleship is very fun.
and I
It's fun.
sucked at it.
Well, the whole purpose of it is it just gets you familiar with the table. It makes you look at it a lot, which is what I want you to do. So we're technically over, but I'm going to give you 1 minute to answer Eleanor's question before I close out the Zoom. So Eleanor wants to know what everybody is going to be for Halloween. Are we even trick-or-treating? I don't even know.
I
what's
know.
going on. All right. Why don't we'll start at the top. D'Antoni girls, what are you going to be?
You need to log on.
I don't know.
Neither of you know.
My birthday's in October.
Oh, is it? Okay.
October 15th.
All right. How about you, Senya? What are you going to be?
Taylor Swift.
Taylor Swift. That's a great costume. Jocelyn, how about you?
I was very
idea.
like,
Wait, what'd you say?
I have no idea.
She has no idea. Lily, do you know what you're going to be for Halloween? She doesn't know. Lily doesn't
Miss
know.
Danny,
Yes.
does Ethan need to do this with me, or do you have another one for them?
It's the same lab, but he needs his own copy.
Oh, okay.
Okay, cool.
He needs his own copy.
last year I was Katy Perry and
He's supposed to log on with us.
Oh, yeah, you guys are going to be on the same screen again?
Cookies.
If you're going to be on the same screen, you can play each other.
Okay.
Okay, but you still need your own copy of paper.
Yeah.
All right, let's see. Anybody else anybody who doesn't have their face up want to tell Eleanor what they want to be for Halloween?
does Scott or Alec or Ella?
Yeah.
Ella's unmuted.
Yeah. I don't know why, because she's right here too. Alec doesn't want to tell.
What's Drew gonna be?
Yeah.
I don't know. What'd you say?
No clue.
No clue. Yeah. All right, well, let me let y'all go, and I hope to see most of you back at 11 if you can, and we'll do our.
I can't because that's the only time my brother can have lunch because of his break, so I can't.
Okay, you can play. You can. All the directions are already sent out in an email, so you can pick. You can do it that way too.
Also, I'm gonna be myself from my own imaginary world,
No,
and
play
I'm
with
making my
a
costume.
partner in your house or whatever. Play it with the partner. If
I'm
you,
not in my house. I'm in my grandparents' house because he just had surgery.
oh yeah. Okay, yeah. Well, play it and then play it with somebody, and then all I need is three. I need three. I need you to do it 3 times because I need to know who you played and who won for 3 games, and that's it. All
I'll
right.
try to play with someone.
Alec is going to be a walking school. I don't know what that is, but that sounds interesting.
How can you be a walking school?
He's gonna be a school that can walk.
Apparently. All right, you guys. I'll see y'all
Walking
later.
away from COVID.
Bye.
Bye. So
Bye-bye.
just log back in. So just log back in.
Yeah, there's a, let me see. There's a link. It's in your email, and you can log into that. Does that work? Okay. All right. See you then.